Hey, it's Mr. Canfield. Wait, why did I say that like you know what this is? You guys have been complaining that I don't film for you. I'm gonna go through the review paper and just, do all the problems. So, toward the end, I've crossed off a couple of them because we haven't gotten there yet. But we need to quiz and see what's going on. So, we're gonna start with the Taylor polynomial stuff and we'll move through it. So, the first one says, find the Maclaurin polynomial of degree n for the following function and use your calculator to compute the error and using the polynomial to calculate f of 0.1, as opposed to using the actual function to calculate f of 0.1. I mean, because like for this first one, we can go e to the 2 times 0.1 and, ooh, I got the answer. Thanks, calculator. But obviously that's not what we're getting quizzed on. Oh yeah, it says quiz. It's review. All right. So in this first one, Maclaurin means it's centered at 0. So that means it's the simpler form of this. And it says we want the 5th degree Maclaurin polynomial. So that means I'm going to need 5 derivatives. So I'm going to need y prime, y double prime, y triple prime, y quadruple prime, and then y quintuple prime. All right, so fortunately, e to the 2x is a very simple derivative to take because it's just e to the 2x every single time, except we have to account for chain rule. So in our first derivative, the 2 pops out. In our second derivative, the 2 pops out again, turning that into 2 times 2, which is 4. The 2 pops out again, times 2, that's 8. 2 pops out again, that times 2, that's 16. 2 pops out again, times 2, that's 32. Wow. Okay, so now if I'm going to go and write my, oh, no. Yeah, okay, thinking, that's good. Good to think. So since Maclaurin is centered at 0, that means I'm going to be plugging 0 in for all of these, including my original y. If I plug in 0 for that, I get 1 because e to the 0, or 2 times 0, if we look at that, e to the 2 times 0 is 1 because it's e to the 0. So for all of these, it's going to be, this e thing is just going to be 1, and we're going to be left with the coefficient out front. So for y prime, we get 2, y double prime, we get 4, y triple prime, we get 8, 16, and 32. And I'm going to use this as an aside since, hey, strike while the iron's hot. You may notice that this 1, 2, 4, 8, 16, 32 is following a sequence. We've been talking about sequences recently. We are going to be able to turn this into an infinite series if we wanted to. Okay, anyway, back to this actual question. So just remember that the formula for Maclaurin, you take your first coefficient, and I'm going to write it the silly way first. It's the first coefficient times x to the 0 divided by 0 factorial, which we've talked about 0 factorial is actually 1. And then our second coefficient times x to the first over 1 factorial. Third coefficient, here's where it actually starts to matter. X squared over 2 factorial. 8x to the third over 3 factorial. Plus 16x to the 4th over 4 factorial. Plus 32 x to x to the 5th over 5 factorial. So, and this is our p sub 5 of x, our approximation polynomial. Then we're going to use this to calculate f of 0.1. So when I'm typing this into my calculator, I'm going to be plugging in 0.1 for x. Now remember, the x to the 0 is actually 1, so I could clean this up a little bit, and I could say that this is 1 plus 2x plus, now 2 factorial is 2, so I can cancel the 4 and the 2 and get 2, so plus 2x squared 3 factorial is 6. So I'm going to be able to cancel the 8 and the 3 and get 8 and it's 3 times 2 times 1. That's how I'm going to do it. This is 4 times 2, so the 2's cancel. So 4x cubed over 3. Here the 16, and it's 16 and 24. So 4 times 3 times 2 times 1. This is 4 times 2 times 2. So I can cancel a 4 and I can cancel a 2 and be left with 2/3. So 2x to the 4th over 3. This is completely unnecessary. You don't need to do this. 5 factorial. We got 5 2's up here. 5 factorial is 5 times 4 times 3 times 2 times 1. So 2 2's and a 4 will cancel. And is this even visible? Yeah. Oh, yeah. Now, is it going to be visible on YouTube is a better question. So we got 4 over 3. Nope. I got 4 on top. I got a 5 and a 3. 4 over 15. So 4x to the 5th over 15. And then I'm going to plug in... I'm going to plug in 0.1. So how in the world are you... All right. There's no... I don't know how you guys deal with this room on these packets. All right. I am definitely going to be moving on to more paper very, very soon. So P of 0.1 is going to be 1 plus 2 times 0.1 plus 2 times... You know what? I'm not typing all that in. 1 plus 2x plus 2x squared plus 4/3. I'm just going to bother somebody. 4x cubed over 3. Woo! Over 3. Plus 2x to the 4th over 3. Plus 4x to the 5th over 15. All right, and I'll go to my table. I already have my table set up with second window to do the ask thing with independent. Then I can just type in that I'm typing in 0.1 in here, and it'll spit out my approximation. And I'm going to go to a lot of decimal places. Oh, looks like it's repeating from there, so I'm going to say 6 repeating. So I do really like to compare this to the actual. So let's see, 2, 2, 1, 4, 0, 2. So it's off here. This is actually where that repeating decimal starts, and that's where we're off. So how far is that? Let's see. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, 10 millionths. So we're accurate out to the millionths place, which is pretty good. That's pretty good. All right. So that's our whole process. I'm going to go through it again in this one. This one says only go to the 4th degree. So let's see, y prime, then double prime, triple prime, quadruple prime. All right. So I'm going to ignore the chain rule at first and just kind of cycle through my cosines, because that's how I like to think about it. It keeps me from making silly mistakes. So cosine's going to turn into negative sine, then negative cosine, then positive sine, then positive cosine. They're all going to have the pi x inside. And just to be clear, that parentheses there is implied. These all technically have a parentheses around that. Okay, anyway. Now, chain rule. So now these negatives, I'm gonna have to fudge it a little bit because I need to put a pi out front here. So negative pi. Then this is gonna be negative pi squared. Then this will be pi cubed and pi to the 4th. Okay. So let's see. Since we're using Maclaurin, it's still centered at 0. So when I plug in 0 for these, let's see, sine of 0 is 0. So these two are going to just flat out be 0. Cosine of 0 is 1. So this is going to be negative pi squared, which is silly. And this one is going to be pi to the 4th. All right, so that means our polynomial, I want to be careful because these zeros are like, oh, I can skip those. But when we skip stuff, we mess up stuff. So I'm going to be really careful and say my p sub 4 of x is equal to my first coefficient times x to 0 over 0. Okay, so it's just 0 plus my second coefficient, negative pi squared x over 1, plus my third coefficient, 0, x squared, plus my fourth coefficient, pi to the 4th. So this is why it's helpful, because it's 0x, x squared. This is going to be x cubed. That 4th right there is making me want to put I made a mistake. Did you catch it? It's subtle because I talked with confidence about it. I missed something super crucial in setting this up. You don't just use the derivatives, you got to use y as well. So let's plug in 0 to our original cosine. We get 1. So my actual first coefficient is 1. So let's try this again. So p sub 4 of x is equal to 1. Now we're going to have 0x, then we're going to have minus pi squared x squared over 2 factorial. Hey, okay, so now we're getting powers matching up. So that was actually a little clue to myself that something was wrong over here. I'm glad I caught that and I didn't have to go back in and edit the video because that takes real actual effort. I don't know how to do that. Oh, I forgot to do this over 3 factorial. This is over 4 factorial. Okay, so strong recommendation. So I'm prone to silly mistakes. This was a silly mistake. It was a mistake of omission. It was I'm rushing. I'm trying to explain myself. Really, really important to kind of scrutinize yourself. Assume you're going to make dumb mistakes. A lot of you guys are already really good at this, but I think some of us could benefit from some humility. Ooh, got a Graham's number going on there. Excuse me. And when I say humility, I don't mean being humiliated. I mean being humble. Just remember that humility is the character trait or the act of being humble. Notice I'm leaving out the zeros. I just said humility is the act of being humble. Yeah, that's not true. I'm mixing up my word types. All right, so remember that 2 factorial is 2, so it's not inappropriate for us to leave that out. 4 factorial is something. It's 24. I'm able to type this in. If you missed how I did that so quickly, if you're on an 84 or an 83, you can go over here to math and push the math button, and you go over to probability, PRB, which you would have learned if you took AP Stat. It's the exclamation point there. So pretty sure I've gone over that in class, but just in case I didn't. So here it is, and if we go into our table, we're just calculating. Oh, 0.1's already plugged in. So p sub 4 of 0.1 is equal to 0.951057849,207. Why am I going to? I'm not going to care about rounding. I'm just going to put the thing there. Walk away. Let the AP exam worry about what I'm supposed to round to. Now, just out of curiosity, I'm curious about what it is. So I'm going to do 0.1 store x, and I'm going to pull up my second calc thing alpha calc to bring up y1 and plug it in. Wait, I just did that. Silly Canfield. All right, so that's that. What about cosine of pi times 0.1? Oh, yeah, that's what I meant to do. Pi x. So that's concerning. Oh dear, did I do something wrong all the way through this? That's only accurate to the 10th place. There's no way. What did I do wrong? Am I in degree mode? Yes, okay. All right, there we go. So, there, delete that degree one. There we go. We got a much more accurate, or accurate to 5 decimal places now. Let's see, 10, 100, 1,000th, 10,000th, 100,000th. So we're accurate to the 100,000th place. Much better. Okay, so I know that wasn't required for those, but it's worth talking about. All right, let's keep going. I'm going to forego going through the whole process for these. I am limited on time and the amount of stuff that I can talk about today, but just remember that the derivative of inverse tangent, because this, if you're going to struggle on this, it's going to be what the derivative of that is. It's 1 over 1 plus x squared. So the derivative of this, I'm going to remind myself that 1 plus x squared to the negative first is identical. So when I take my second derivative, I'll just use chain rule, bring the negative 1 down, get 1 plus x squared to the negative 2. And then I got to do chain rule, so I got to do times 2x. Oh, joy, right? This is great. Oh, but it only has me do one more derivative. So I think this is going to be easier to leave as a product instead of turning it into a quotient, and doing quotient rule. Whatever you want to do, it's fine. So triple prime. I know some of you like to do first d second plus second d first. I think that that's, it's harder to remember quotient rule if you do that. So I'm just going to do the derivative of the first one, and then I'm going to do the derivative of the second one second. So derivative of the first one is 2, 1 plus x squared to the negative third, leave the 2x alone. Then take the derivative of the second one, which is 2, so it's going to be negative 2 out front of my 1 plus x squared to the negative 2. Remember, if you do it differently, it'll just be reversed. So once we're there, it's Maclaurin still, so we'll plug in 0, we'll get our function. Yeah, then we'll go through, do it, it's normal. All right, so let's talk about this one. Find the Taylor polynomial of degree 3. So we need 3 derivatives for the function y equals the square root of x centered at c equals 4. All right, so y is equal to, so last time I forgot to do that. So I'm going to remind myself now by doing y is equal to square root of x. And then centered at c equals 4. That means that y is equal to 2. Y prime is going to be 1/2 x to the negative 1/2. I'm leaving it like that because I'm going to be doing multiple derivatives. It's going to make it easier. So when I plug in 4, sorry, I get 1/4 because this is really saying 1 over 2 root x, so 1 over 2 times 2. And again, if you don't believe me, just plug it in. Wow, there it is. If you push the math button, it will turn it into a fraction. Woo! All right, so that's y prime, y a double prime. I need to go all the way to y triple prime, so multiply by negative 1/2, I get negative 1/4. X to, why am I putting in prime, or whatever, to the negative 3/2, we subtract 1, y triple prime, oh wait, plug in 4 here. This is a little bit trickier, so I'm actually going to show my work. So 1 over 4 times 4 to the 3/2. Canfield, what are you doing? You trying to give people eye strain? Yes. So 4 to the 3/2 we take the square root and then we cube it. So that's going to be 8. So equals -1/4 times 8, which is -1/32. All right, triple prime. We're going to multiply the -1/4 by -3/2. So that's going to be 3/8 x to the -5/2. So 4 to the -5/2 should be, what is it? 1 over the square root of 32. I mean, sorry. Just 1 over 32, not the square root of 32. So then I gotta do 8 times 32. Yeah, no, that's not what I meant to do. 256, all right. So 3 over 256. Cool, okay. So if I'm centered at c equals 4, then, so we'll find our polynomial, and our polynomial is gonna be, let's see, so p of x, third degree is equal to, take our first coefficient, x to the 0, then our second coefficient, x to the 1 over 1 factorial. So again, that's 1/4 x to the 1 over 1. Then our second one, we're gonna be divided by 2 in this one, so that's actually gonna be 64. So x squared over 64. Because remember, we're gonna be taking -32 times x squared over 2 factorial. And we're gonna have to find out what that is. So then plus 3x cubed over 3 factorial. So I'm going to be taking 256 times 3 factorial and getting 1536, you know. Wait. 3 over 1536, that's going to simplify super nicely to 1 over 512. Just kidding, not super nicely. 1 over 512. So if you're noticing here, this is over 1, 4, 64, 512. We're multiplying by 4 every time. So that pattern is reassuring to me that I'm doing things right. However, I did something very wrong. Did you catch it? It's not centered at 0. This is centered at c equals 4. So these x's are not x's. So it's not a Maclaurin. I can't just put x's. I have to do 2 plus x minus 4 over 4 minus x minus 4 squared over 64 plus x minus 4 to the third over 512. So if you're working along with me and you made the same mistake as me, just, you know, let's use that kind of as a jarring reminder. Like Maclaurin is the easy one where it's not gross, and Taylor, we have to throw that stuff in. So so now we move into Lagrange, right? So we're gonna be plugging in 4.05. Ew. So for simplicity's sake, I'm gonna type this in here because it makes life easier. Being careful to enter things where they belong. All right. Cool. So that's there, and I'm gonna be plugging in 4.05. So I go to my table, 4.05, and I get P of 4.05 is equal to 2.01246111. Oh, that's too many ones. 8164. Okay, so I want to find. Oh, I'm done. Okay. I thought I was doing Lagrange error. Silly me. Okay. that makes more sense. I was like, that's really intense for one problem on a quiz. All right, so now we're gonna move on to this. So the quiz is not gonna be this long, don't worry. I wanted to throw all the stuff that we've been learning at you to make sure that you are comfortable, make sure you've got what you need. I'm trying to give you more collegiate style quizzes where I'm not just like, hey, do this problem. Oh, here's the quiz. It's the same problem. Like, that's not the way stuff works. Like, you don't show that you understand if you do that. I can hear some of you going, yeah, but my grade. You're gonna be fine. Let's see. Let f be a function having derivatives of all orders for all real numbers. The third degree Taylor polynomial for the given function is bleh. All right. So, what's this plus 4 telling us in here? It's telling us that it's centered at, well, remember it goes x minus c in there. What do we have to subtract to make it say plus 4? Negative 4. So it's centered at negative 4. So f of negative 4 is literally just that first coefficient. So f of negative 4 is 4. I really wish he asked us for f prime of 4. Because check it out. We just skip straight from, did you catch that? It was, yeah, okay. Let's start over. Calm, cool, collected. So we skip straight from 4 with no x to x squared. That tells us we skipped x. That actually means that f prime of 4 is equal to 0. I think that's going to come back a little bit later in the problem. All right, so let's see. F double prime of negative 4 Canfield. The shamelessness of uploading a video like this with so many errors. You know, if enough people watch them and complain, I'd probably redo them, but nobody's complained yet. So, f double prime, well, if we think about this, 3 times x plus 4 squared is equal to f double prime of negative 4 times x plus 4 squared over 2 factorial. You know, that's that second term in p of x. And so if that's, or the third term, sorry, that's the x squared term of p of x. So because that's the case here, if we, divide out the x plus 4 squared, 3 is actually equal to f double prime of negative 4 divided by 2. So f double prime of negative 4, we have to multiply both sides by that 2 factorial and get 6. F double prime of 4 is actually equal to 6. I keep saying 4. I hope you understand. I'm meaning negative 4. So f triple prime is going to follow suit, negative x plus 4 cubed is equal to f triple prime x plus 4 cubed divided by 3 factorial. And if we divide out the x plus 4 cubed, then we're going to get negative 1 over here. I got to multiply that by 3 factorial, which is 6, and we get negative 6. So that's f triple prime is equal to negative 6. All right, I love this next question. Is there enough information to determine whether f has a critical point at x equals negative 4? If not, explain why not. If so, determine whether f of negative 4 is a relative max, a relative min, or neither, and justify your answer. Okay, so we've already laid all the groundwork here. We just have to explain ourselves. So we know that f prime of negative 4 is equal to 0 because of this. So yes. I'm gonna try to explain myself as if I wasn't talking to you, as if I was trying to get graded on this. The x to the first term is missing, indicating, of p of x. Put a little caret there. So the x to the first term of p of x is missing, indicating f prime of negative 4 is equal to 0, which makes x equals negative 4 a critical point. So determine whether f is relative maximum, relative minimum. Be right back. Okay, I'm back. So we want to determine whether f of negative 4 is a relative max or relative min or neither. Neither. Which one? Okay. I before e except when it's neither. All right, so isn't it so bad when you make yourself laugh with stupid jokes? Okay, so on its own, like I can't do a sign chart here and go, okay, let me plug in numbers a little bit to the left of negative 4, a little bit to the right of negative 4, but I can look at the concavity of f by paying attention to f double prime. I know f double prime is 6. That means at negative 4, our function is concave up. We have some kind of concave up. And so if we've achieved a critical number and it's concave up, the only way for that to be the case is for negative 4 to be a minimum. So here's me finishing. Since f double prime of negative 4 is greater than 0, f of x is concave up at x equals negative 4. I'm going to use the word indicating again because I just can't be bothered to use fancier language. Indicating a relative minimum at f of negative 4. So I've got like 8 minutes left to finish this. There's no way I'm going to finish the rest of the packet, but hopefully this has been helpful. All right. Use p of x to find an approximation for the y-intercept of f. Is there enough information to determine whether f has a critical point along the y-axis? If not, explain why not. If so, determine whether the critical point is a relative max, relative min, neither. Justify your answer. Okay. This is the first one that I'm running into where my brain's like, uh-oh, what's going to happen? So let's slow down, be careful, and just think about it. So y-intercept for f. Well, a y-intercept means that x is equal to 0. So if I'm going to plug in 0 here to my p of x, that is an approximation. That's 4 away though. That makes me really uncomfortable. The farther we get away from our center, the less accurate we are. And 4 away is pretty far. But if I plug in 0 here, that'd be p of 0 is equal to 4 plus 3 times 4 squared, minus 4 cubed. So 4 plus 48 minus 64. That's me just flexing, making sure you know that I know how to take 4 and 2 different powers to it. I just don't want to make mistakes. So negative 12. Is there enough information to determine whether f has a critical point along the y-axis? So if I understand this question correctly, it's saying when x is 0, is f equal to 0? I mean, I'm going to have to go back and double check myself here, but if p of 0 is equal to negative 12, so my approximation is negative 12. It's saying, hey, f is somewhere around negative 12. Okay, so if f has a critical point, it's not asking if p is equal to negative 12. It's asking is f prime equal to negative, or is f prime equal to 0 when x is 0? My brain is getting scrambled. I'm going to pause really quick. I don't want to take too much time. All right, I'm back. So gut reaction here was like, there must be a way for us to know this, and that's where I kind of assumed the answer and said, how do I get to the answer? And so I was trying to get there and really getting confused, realizing that it didn't necessarily have to be the case. And so if we think about this, is there enough information in this problem to say that f prime of 0 is 0? And no, there isn't. There's not enough information. This gives us a neighborhood of -4, and we know stuff about -4. We don't know anything else about this. We don't know anything else that happens besides, the information that we can draw about -4 and its neighborhood around there. So thinking more about this problem, I always try to get inside the head of the person asking the questions. What are they trying to ask me? Well, they're really trying to see right here is, do I get that this isn't a Maclaurin polynomial? Because if it was Maclaurin, it'd be centered at 0, and it would make sense. So that's the big difference here. So we've got -4, and then we have something about 0, because if we don't get what's going on here, we're going to think it's Maclaurin. Oh, it's centered at 0. Like, these are all about 0. And anyway, no, there's not enough information because our polynomial is centered at x equals -4 and only useful in that neighborhood. Okay. I probably could say this better. We'll talk about that later. All right, fourth derivative of f satisfies this inequality. Let's see, for all x interval, use the Lagrange error bound on the value of the y-intercept found in part C above to explain why the y-intercept must be negative. Okay, so it says the fourth derivative of x is less than or equal to 11/10. So remember when we're talking about Lagrange bound, the idea was what's the biggest it could possibly be, and that's what we use for our next term. So we think about our x plus 4 to the fourth over 4. We'd put 11/10 outside here, and this is like our remainder. So if we're looking at 0 and we plug in 0 here, then our remainder is going to be 11/10 times 4 to the fourth, which I believe is 256. There's the bell. I'm going to have to come back to this. Might even trim the video and just cut this part out. So don't know why I'm talking to you. Canfield out. Have a good one.